Hello everyone. So today we'll perform another practical under a data analytics lab. So in this practical, we are going to use a machine learning prediction model for predicting 3D printer parameters using MATLAB. So as we know, there are different steps we have to follow in developing a prediction model. So first step is we need data. So we have to acquire data. That may be a generated data or you can say sensor data. Then after getting data, we have to pre-process the data. After pre-processing, we need to develop detection or a prediction model. Under this, we have to identify condition indicators, we have to train the model, we have to test the model. And once we train and test the model, then we need to deploy and integrate the model. So these are some basic steps that we are going to follow during this practical. I'm just giving you a background before starting actual practical. And the data set that we are going to use in this practical, this data set comes from a research by TR at a Selkirk University Mechanical Engineering Department. And the aim of this study is is determine how much of the adjustment parameters in 3D printers affect the print quality, accuracy, and strength. Where there are 9 setting parameters and 3 measured output parameters. We'll see these parameters. So the setting parameters are layer height, wall thickness, infill density, infill pattern, nozzle temperature, bed temperature, print speed, material, and fan speed. While the output or the measured parameters are roughness, tension strength, and elongation. The basic aim of our practical is to estimate which material is used from input and output parameters using different machine learning algorithms. So our first step is pre-processing the data. After getting data, we have data set. So we need to pre-process the data. So I will start with actual practical now. So first step is just pre-processing the data. In order to do this practical, we need MATLAB software. So I'll just use MATLAB Online here. We need to log in. I'm already logged in here. So remember, we are using the MATLAB Online of a MathWorks platform. It is taking time. Once it is loaded, then we start. Okay, so you can see now, once we click on MATLAB Online, this kind of window will open. And here, first step we have to do is we need to import our data file. So I'll just click on upload. As you can see in my folder, already these files are there. But we can, as a procedure, first step is to upload the file. So I will upload this file, dataset file from my drive. This file is saved as a data. So I'm just going to upload this CSV file. It is asking whether we can replace. Yes, I'm saying replace all files and upload this current file. Okay. Now this file is there in my current folder, but still it is not in the workspace. So in order to get it in workspace, I have to import this data. Click on import data. You can see there are 2 files are there. So I have to import data.csv file and then click on open. So first step you have to upload and then import. You can see once I click on import file, this data set is there in my workspace. You can observe there are 50 rows and 12 columns. Okay. So there are 50 instances are there. Okay. You can observe 51 because the first instance is of this parameters names. Okay. So there are 50 rows and 12 columns are there. So now data set is there in our workspace. What we can do here is as a part of pre-processing, you can check whether is there any empty cells or cells are there or not. If we know that if there is unwanted data, that we need to clean the data. So data cleaning is one of the important step. So we can do it in MATLAB. See how we can do. Here it is replace unimportable cells with NaN. So we can, if I click on this plus button, I'm just showing you how we can do the pre-processing. That is, we can do data cleaning. So it is asking replace. What to replace? There are different options like unimported cells with. We can replace unimported cells with either non-Na value, unimportable cells. Okay, sorry, unimportable cells with either NaN value, or we can use another value. So if you want to, you can mention value either 0 or whatever value we need to mention that we can replace. Also, we can exclude rows with empty cells or unimportable values. Then we can also exclude columns also. You can say exclude columns. So this is what how we can perform a data cleaning using MATLAB. Also, you can see our selection now. Initially now A2 to L51 means all are selected. If I select only one, you can see here in selection history it is showing A5 to A5. Only one cell is selected. So you have to take care while selection also. Now I have to click, select entire data. So you click here. Now you can see in selection history it is showing A22L51 means all cells are selected. Okay. Once by selecting all this data, we have to click on import selection and then import the data. Okay. You can see these 50 rows and 12 columns is there. It is there in my workspace now. After this, the first important step is just we need to select a learner for our algorithm. You can see there are different types of learners are there. We are going to select classification learner. So I'm just clicking on classification learner. It will take some time and a new window will pop up. So you can see this one is classification learner window. Okay. Once this window is open, then we need to click on new sessions. And as already file is there in our workspace, I will click on workspace. If file is not there, then you can from file also. But okay, I will click on from workspace. Now here you can see uh, already data set is known to you. Now there are 50 rows and 12 columns. What 12 columns are, I already explain you. If you want, I will explain again. You can see in our data sheet. I will explain this data sheet first. So we can see there are 12 features like layer height, wall thickness, infill density, infill pattern, nozzle temperature, bed temperature, print speed, and material. Then fan speed. So these are the input parameters, or you can say setting parameters. While these three fans, this also setting parameter. While last three, roughness, tension, strength, and elongation are the output or measure parameters. In this practical, we are going to predict based on this 12. So there are 12 features, some input and some output features. In this practical, what we are going to do, we are going to develop a prediction model for selection of material. So we should be able to select a material based on other parameters. You can see initially in the data set, we have the material values are given. The material is either ABS or PLA. And if you want to learn about a data set, there are 50 rows, 12 columns. I already told you. You can see from this data set, only infill pattern and material is having categorical values, while other columns are having number values, or you can say numeric values. So we have to develop a prediction model to select a material based on other features of this 3D printer dataset. Okay, now see, so once I click on classification learner, it is asking you have to check our dataset. Yes, it is data 50 by 12 columns, 50 by 12 rows and 50 rows and 12 column dataset. Then here we have to check response and predictors. As I'm going to predict material, therefore my response is material. We know the data type is categorical data, while predictors are other features. You can see here other features are tick here, but only material is untick because material is my response and others are my predictors. So we can select response and predictors here. After that, as a machine learning algorithm, we know there are different cross validation techniques. And here I'm going to select under cross validation. I'm going to select 5-fold cross validation here. So I'm going to select 5-fold cross validation. Just click on 5. That is already 5. You can change this value if you want, but I'm going to take 5-fold cross validation. And we know uh, as a machine learning, here we need to set some test data and train data. So for testing, we can set different proportion. Here also we have facility to select test data set. So for testing inside the MATLAB, what we will do is I just have to click here, and then you need to select percentage. How much test data you want? So I'll select either 30% or you can take 20%. Let's select 30% data for testing. Okay. And once you select test data set percentage, then cross validation technique, your response and predictors, and once you confirm your data set here, then you can click on start session. So by default, you can see here it is selecting tree. Okay, so tree is by default selected, but I'm just going to show you some different features here before going for training the data set. In this tab, you can see here we can select features. So feature selection is one of the important step that you can do. What is feature selection? We know for feature selection there are different algorithms are available like MR, chi-square or ANOVA. These algorithms are used to rank our features. So we can give some ranking to our features and based on our we can say priority. So we can select any one algorithm here. Now it is clicked on none. So I'm not going to give any priority or not going to give any ranking to my features as all features are important for me. But you can do it with different algorithms. So let's say we are clicking on ANOVA algorithm. You can say ANOVA algorithm. What it is doing now, you can see it is calculating ranking based on its requirement, based on its importance. So highest ranking is obtained for nozzle temperature. Likewise, you can see the ranking by ANOVA. And so we can use these algorithms for ranking. Either you can use ANOVA or chi-square or MRMR. But as I don't want to give any ranking or priority to my features, I'm not going to select this. I'm just clicking on none. But if you want to save, if you want to apply it, yes, you can have to click on save and apply. But I'm not going to apply it. Just I'm showing you how you can give different rankings or different priorities to your features. So this is what important step that is called the features selection. I'm going to click on none. Okay. And also along with this, there are some options also available. That is PCA, principal component analysis. That also we can perform here. Just we have to click on enable PCA, and here you can see PCA basically used to reduce the components to specify the number of components. So you can reduce the parameters. Okay, either it is in percentage or in numbers. So you can reduce the features here. Now instead of 11, you can take 10, 5, 6, whatever you want. So I want to tell you, yes, of course we can do PCA also in MATLAB. I'm not going to use PCA or any feature ranking algorithms. Okay, so now I have to select a model or a classification learner for my training purpose. Okay, so what I'm going to select, we have to select one classifiers for this training the data. There are different classifiers are available like logistic regression, Navy by classifiers, support vector machines, then nearest neighbors classifiers. But I'm going to select all SVMs for training my data. So I'm going to select SVM as a classifier. I selected on all SVMs because there are different SVMs are available. You can see So I selected all SVMs here, and after selecting all SVMs, just we have to click on train all. Instead of train all, we can click on train selected because I have to use all SVM for training my dataset. So I just click on train selected. Once you click on train selected, you can see it is training our dataset. Okay, and it is applying all SVM models. Now there are different SVM models. You can see training is going on. So you can see there are different SVM models like a linear SVM, quadratic SVM, cubic SVM, fine Gaussian, medium Gaussian, and coarse Gaussian. As a summary, you can see here. So we have yes, training is done, and you can see the different accuracy of different models. That is linear SVM having 100% accuracy, quadratic having 97% accuracy, the cubic is having 91%, and likewise. If you want to select this SVMs as per accuracy, just you have to click here. Then you can check. Yes, it is showing you as per accuracy. So highest accuracy is obtained in a linear SVM model. You can see here in linear SVM accuracy 100%. These are the parameters that gives you information about training parameters like what is total cost, the prediction speed, training time, and all. So till now we did done with training a data set. We use SVM model for this. We can also draw some plots of a trained data set like confusion matrix. So I just click on this confusion matrix. You can see here 17 plus 18. These are the our trained data sets. Okay. You can save this image also here by clicking here. So we can plot a confusion matrix. We can plot a scatter plot also if you want. And also we can go for a ROC curve. So we can plot different graphs and plots. This feature is available with MATLAB. Okay. You can see in confusion matrix, it takes 17 plus 18. So we have selected 30% data set for training and 70% for 30% for testing and 70% for training. So 50 rows are there. So 50 into 70%, it is 35. So this 17 plus 18 means you can see it is trained data set now. So training results. So 17 plus 18 means it is 35, which is a 70% of our entire data set. Now after this, we have to test our data set, and for testing, you can see here testing. I'm going to select highest accuracy one. That is, I'm going to select linear SVM for my testing. So I selected linear SVM and just click on test. So not all models, but test selected. So it is going through testing. You can check summary if you want to confuse. Testing is done or not. You can check. Okay. Okay. You can see here now. SVM we have used for train highest accuracy for training, and then the test result is 100% accurate, and cost of course it is 0. So our testing is done. Once testing is done, we have train our model, then we test our model, and we have to export the model. So just click on export model. Here we need to give some name. As I'm calling it as a train model. Okay. So remember this name. We are using name as a train model. Just click on OK. It will take some time. Okay, so it is done. We export our model, and you can see this our model here. So you can see here train model is exported here as one by one strut. Now we are ready for our prediction. So what to do here in this case? As we know, we need to import our trial data set also. So I click on home, and you have to upload our trial data set. Already I uploaded previously, but I'll show you how to upload it again. So I have to upload my trial data set. You can see in trial data set, I save it as trial data set. And first I will show you that what data set it is. Okay. Yes, this one. So you can see here as a trial data set, we kept this material column blank because we have to predict the material based on these features. So I'm going to use this data set as a trial data set. You can see there are near about 25 rows, that is 24 rows and 12 features with this material column is empty, or you can say not having values, and we need to predict these values based on our train and test results. Okay, so I'm going to use this trial data set for yes. Uh, okay, I'm going to upload it. Once it is uploaded, then I have to import it in a workspace. Trial.csv data trial data set. It will be imported in workspace now. You can see this material column is empty here. Okay, now once it is in our workspace, what to do is you can check here in command window. I have to first I'm using one command called as a push, just to check. Yes, there is data sheet, train model, and uh, are the available. Struts are available. Train model is there and data is there. Okay. After this, we have to fit a prediction model. For prediction model, we can see this command. It is provided by MATLAB. So y fit is equal to, that is we have to predict this y based on uh, command called as train model dot predict FCN of t. So t is our trial data set. Okay. So what I'll do here, I'll call this our data set as A, and it is equal to, you have to use command called the read table. You can see there are different options available. I have to use trial data set and just enter. So what I'm doing here, as a trial data set, I have to call t. Instead of t, I'm calling it as a. So I can use this a here in this function, in this command. So I'm calling my data set as a using read table function. Just click on enter. Okay. So it's working, and now this data set is called as a. You can see our material column. It was empty, but it is replaced by NaN values by MATLAB only. We have not done anything, just it is imported here, and it is replaced. That material column is replaced with NaN values by MATLAB. After this, I have to use this command called as a yfit is equal to train model dot predict top data set. So I'm going to use it here. So what change I have to do is, just instead of t, I'll call give my name, that is my data set name, trial data set name. As I save it as a, I will use it here and just enter it. I just enter. You can see our prediction model is developed, and we are able to predict material based on these 9 features. So we are able to predict material, that is ABS or PLA, based on our requirement based on 12 features. So we can copy this, and I will check in my trial data set. You can paste it here. Okay. So likewise, we can do prediction. We can develop prediction model using MATLAB. So this is our results. So I just revise once again what we did in this practical. It's very simple. Just we need to upload and import data sheet. After that, just we have to select our classification learner. Then we have to train our data set using different algorithms. We selected, yes, we selected which one? SVM as a algorithm we selected. After SVM selection, that is training our data set, we are going to test our data set. And for testing our data set, we select 30% as a percentage for testing. Then we need to import our trial data set, and just after importing, just we have to use some commands like yfit is equal to train model dot predict of this function, and I called my data set as A. Finally, we get results of our material prediction based on the prediction model we used. Okay, so this was overall summary of this practical. Thank you.